Good morning. Yesterday, I think it was yesterday, I did a video where I offered three, I called them outlandish suggestions about what to do with the Roaring Spring paper mill site after it's cleaned up. Outlandish was maybe a bad choice of words. One of the reasons I thought of that word was because some of the input for that, much of the input for that comes from out of this land. Portugal, Switzerland, for example, are major, Italy, as you'll see. And I'm going to return to that with at least three videos. One on the idea of a water wheel publicly for display and power, but primarily for beauty. Two, for hydraulic funicular, an inclined plane, if you will, driven without any electricity or fossil fuels, just with water powered. Curiosity for tours for use if it's done well enough. And the third was a botanical garden. Each one of those deserves at least one video. But I want to go on to one other thought about that area. And that is all that water supply that's continually and for probably hundreds of thousands of years, probably at least tens of thousands of years, has been coming out of that spring. And what a resource, and what to do with it. Well, I have an idea. Because those other three things I mentioned, they wouldn't take much water at all, and very little. But what about all that water all that time? Well, it can be converted into power for a start, but it can be converted into power, mechanical power, electrical power, hydrogen, oxygen, ammonia, urea, and fertilizer. All of that stuff can be done without being huge and major. And that may seem a little unbelievable, but let me explain. When you've got a strong source of water, steady, but not an enormous flow like a river, and you've got a height, they call it the head, that the water can fall within a short distance. That combination of high head and steady source means that you can build a water wheel or turbine without a dam. You don't need a dam. And there are many of these in the world. What you do is you hold the water in a penstock. Now the penstock is a pipe, and it's got to be strong enough to hold that pressure. It's usually steel sections bolted together, extremely strong, coming down nearly vertically on a mountainside, and driving not through weight, like this example behind me that I'm working on. This is an overshot water wheel. It works on weight and potential energy, you might call it, as opposed to kinetic energy, potential energy. And these, at their very best, can approach 90%, 80% anyway, efficiency, overshot water wheels. With the Fitz water wheel was kind of like the peak, but it wasn't made out of sheet metal. That's what's different about this one. This one is now cardstock, but it's going to be sheet metal. But anyway, the other, when you've got a penstock, what you're working on is pressure. The weight of the water, sure, but being delivered under high pressure, high velocity through a nozzle. And it's just like taking a hose and squirting it at, say, a bicycle wheel up in the air, and it will just spin it just because of the friction on the wheel. Well, those wheels, the most famous of them all is the Pelton wheel, P-E-L-T-O-N, Pelton wheel. And they approach 90% efficiency. They can be small. I mean, you can buy them if you just want to buy everything right now for probably $15,000. You could set up a Pelton wheel generating electricity, a tiny amount, just with plastic pipe. My neighbor was going to do that, but he realized it was going to be $15,000, and he didn't think it was worth it. Well, for one thing, the water supply here isn't steady. Uh, uh, well, anyway, but they can be much bigger. In Switzerland, a Pelton wheel might be 15 feet high, maybe, and very heavy. And what they are is the jet is aimed at a pair of buckets right there in between them, and that water hits that and spins, shoots out the sides, back, and then drops, and then hits the next one. And there's usually a V in there. They're beautifully made, but a little tricky to make. Those pairs of buckets. That's a Pelton wheel. And as I say, Switzerland has lots of them. You can recognize the penstock coming down the side of a mountain, and I'll show you some videos that in which you can see this. I'll give you links, not right now. But all right, so that's a Pelton wheel set up down there by where the sewage treatment plant is, or as low as possible. And with the water being taken down through a penstock, which basically the town wouldn't even see. It could be almost part of the storm drain system, but it would have to be very strongly built. I don't think it would have to be steel. I think plastic, or whatever they call that stuff, would be strong enough for that height. And I estimated, or I didn't estimate, the measurement at the spring is 8.3 cubic feet per second. That's the supply of water, and that's a lot of water. It's steady. It doesn't. It's not very much affected at all by drought or heavy rains or no rain. It's just a steady outlet from apparently a subterranean lake. So 8.3 cubic feet per second, CFS. And the height, the drop, I tried to calculate that. If I had an altimeter, I could go into Roaring Spring and I could probably get a pretty accurate measure. I tried to use the contour lines on my topographic map back here, and that was hard to do because those are on 10-foot increments, and it's so complicated down in there at that area around the paper mill site that it's really hard to count all those lines. But I would say that the drop is somewhere between 100 feet and 140 feet. So I'd take 120 feet, say, as an average. That's my estimate. Given those two things, you can then go through calculations that'll give you the horsepower available, depending on the efficiency of the wheel, how much kilowatts that could make, how much hydrogen, how much oxygen, and ultimately how much green ammonia. Because once you've got ammonia, then you've got well, it's the most widely produced chemical in the world, ammonia, and then you're on your way to making nitrogen fertilizer. Now, and the world depends on that. There's tremendous demand for it all the time. But the catch, it's feeding something like 3 billion people in the world are being fed because of ammonia nitrogen fertilizer. But they call it green if it's not using any fossil fuels. And now that's possible. The catch with nitrogen fertilizer is the Haber Bosch process, which is used, has been around for a little over 100 years. It also makes poison gas, pesticides, herbicides, fungicides, I think a lot of plastics. But what it does is it pulls the hydrogen out, or I think out of the of natural gas mostly. It uses a tremendous amount of fossil fuels, something like 14 times more fuel goes into it than comes out. Oh, and it also makes explosives. And it's going to be limited. It's not sustainable. But there is a process now available. Another thing, it takes 450 degrees centigrade conditions and something like 200, maybe they got it down a little bit, 200 atmospheres of pressure to make that. And yet it's being made, it consumes as much energy as the entire airplane industry. air travel industry in the world. That's how big it is. Well, anyway, there is a company now, or well, they can make it now. So where all you need is water, air, and electricity. With those three ingredients, you can make nitrogen fertilizer now. Uh, Where's the electricity come from? Well, if it comes from solar or wind or water power, it's called green. Then it's green nitrogen. You can check it out. It's pretty interesting. Well, anyway, that supply in Roaring Spring could, as a default, as a whenever the water wheel or the botanical garden or the funicular isn't using it, or beside what they use, which would be very little, it could steadily be producing that. I think it's the perfect industry for that spot. It might not employ that many people, but it would bring in money. And again, the tourist industry, I think ultimately is going to be the really big one for Roaring Spring when this and some other things I'll tell you about is done. Bye for now.